Welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். வாரி மெடிக்கல் அகாடமி சார்பாக இனிவரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய ஃபேக்கல்டி மெம்பர்ஸ் லைவ் வீடியோ ஸ்ட்ரீமாக உங்களுக்கு கொடுக்க போகிறாங்க. விஸ் யூ ஆல் தி பெஸ்ட் மை டியர் ஃபியூச்சர் டாக்டர்ஸ். டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் வாரி மெடிக்கல் அகாடமி சார்பாக கொடுக்க ரெடியாக இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க, உங்க ஃப்ரெண்ட்ஸ்க்கும் ஷேர் பண்ணுங்க, அவங்களுக்கு யூஸ்ஃபுல்லா இருக்கும். Thank you.
Welcome students. My name is Gopal. I am chemistry faculty which is working in Vari Medical Academy. Today we are going to see about organic compounds, the classification of organic compounds, how we are classified, because organic chemistry and organic compounds are so vast, so we have to classify, so then only we can get some more concepts in this chemistry. Okay, so on the basis we are going to divide acyclic compounds and cyclic compounds. Acyclic compounds are nothing but that is in open chain. Okay, so where we can see the compounds in open chain, there will be no branching. So for example, here we can say CH3, CH2 and CH3. So this is propane. This is open chain, so there is no any cyclic or bicyclic compounds. So this is acyclic compounds or nothing. In simple we can say open chain compounds. And then another one is cyclic compounds, in other words closed chains. So we can see cycles like benzene. So these compounds, the starting point and end point will be same. So here if we start here, the end will be the same carbon, so that is closed chain. Okay, so in acyclic compounds again we are separating into two categories, that is saturated and unsaturated. Saturated means there will be single bonds in every carbon will have single bonds. Unsaturated, to contrast to that one, multiple bonds, that is in double bond or triple bond. Okay, so this is unsaturated compounds. Saturated means all are single bond. Okay, so saturated we will know that saturated alkanes, right? Alkanes means CH2 Cn H2n plus 2. So here the branch of compounds are alkanes. Okay, hydrocarbons, that is alkanes. All are single bonds. Okay, so all are single bonds, so saturated compounds. And unsaturated is nothing but double bond or triple bond. Those are alkenes and alkynes. Okay, what is the general formula for alkenes? Cn H2n. For alkynes, Cn H2n minus 2. Okay, so these general formulas are very important, since the saturated carbons have one carbon will have 4 bonds, those are all sigma bonds. Okay, unsaturated carbon will have double bond or triple bond, that is alkenes or alkynes. Okay, so this is all about acyclic compounds. Acyclic compounds and cyclic compounds are closed, as we know, that is cyclic compounds are closed one. So again we are going to classify into two subsections, those are all acyclic and aromatic. Acyclic means there will be a cyclic compound but there will be no any aromaticity. Okay, so the aromaticity has been explained by Kekulé or Huckel's rule. So Huckel's rule where we determine the aromaticity of compounds. Okay, so homoatomic and heteroatomic. Homoatomic means the cyclic will be made up of only one type of atoms, that is in like this. So where there are 6 carbons, right? So these cyclic compounds are only made up of same type of atoms, that is nothing but carbon. So in other words, that is carbocyclic compounds. Heterocyclic means this is also cyclic type, but the atom will be differ. For example, this one. Okay, so these are all alicyclic compounds. There will be no aromaticity will be witnessed. So homoatomic and heteroatomic. Homoatomic only made up of same type of atoms, and heteroatomic some other atoms will be substituted. So carbon, nitrogen, sulfur and boron. So these set of elements can be substitute any one of these carbon. So where we can get heteroatomic cyclic compounds. And next one is aromatic. This is very important one. And aromatic is, as we know, aroma, right? Aroma means some fragrance or some some fragrance. So it means some fragrance we can see. So there again can be divided into three subsections: one benzenoid, a non-benzenoid, and heteroatomic compounds. Benzenoid means the aromaticity will be explained by benzene. Benzene as bases and benzenes like benzene and naphthalene, anthracene. So these are all benzene consisting compounds, all are aromatic. Okay. And non-benzenoid, this is also aromatic compounds, but it will not have benzene as a molecule. Okay. For example, and this one, these are all aromatic but are non-benzenoid compounds where we could not see the benzene as base molecule. Okay. So next one is heteroaromatic compounds. Heteroaromatic. Hetero means always there is different in sense. Okay. So heteroaromatic compounds in where pyridine is well known example for heteroaromatic compound, and these molecules are heteroaromatic compounds. Okay. So this is all about organic compounds, and again I am once again going to reiterate, we can divide into acyclic compounds and cyclic compounds. Acyclic compounds can be divided into saturated and unsaturated. Saturated means all are in single bond. Unsaturated we will have double bond and multiple bonds. So saturated in the sense as in the hydrocarbons, that is alkenes. Okay, in general formula for that is CnH3n plus 2, where we could see that carbon will have four atoms attached with singly bonded. Okay, so next one is unsaturated compounds. There carbon bonds are either double bond or triple bonds. So if we change the unsaturated compounds into saturated one, we have to add some other molecules, add some atoms to reduce the number of bonds between carbon atoms. Okay, so then only we can end up with saturated carbon. So this is very important one. If we do hydrogenation and halogenation and hydrohalogenation and addition of water, so these sort of reaction will explain saturation to unsaturation to saturation. Okay, and next one is cyclic compounds, acyclic and aromatic. Acyclic are nothing but homoatomic and heteroatomic. Homoatomic, the cyclic fragment will have same type of molecule, same type of atoms. Okay, so it will be built up by same type of atoms, that is homoatomic. And heteroatomic, again that is a cyclic compound, but there will be some heteroatoms are there. Okay, for example like this N, so we could see oxygen, nitrogen, sulfur, boron, those elements can be present in this cyclic fragment. Okay, that is heteroatomic halicyclic compounds. And next one is aromatic compounds. Aromatic compounds are very, very important one, that is aroma in the sense fragrance. Okay, so again it further classified into three sections: benzenoid, non-benzenoid and heteroaromatic compounds. Benzenoid, the aromatic compounds will consist of benzene as a base molecule. Okay, so that is benzenoid. Non-benzenoid, since it is aromatic but there will be no benzene as a base molecule. And heteroaromatic compounds, again it is aromatic compound but there will be heteroatoms like nitrogen and oxygen, sulfur. So pyridine, furine, thiophene, these are all the molecules are example for heteroaromatic compounds. Okay, so in that we are going to look up into saturation and unsaturation. So that will be okay. So next one is hybridization of carbons in organic compounds. So hybridization is very important one, because how the atomic orbitals of carbon is hybridized into to give different type of molecules. Okay, so as we see before, there is saturation and unsaturation, right? So this is saturated molecules. Alkanes are saturated molecules because the carbon is bonded with 4 atoms, that is in singly bonded. So that's why this one is saturated molecule. And this one, and alkynes, this is alkenes. Alkenes are saturated, alkenes and alkanes are unsaturated. So carbon is bonded with double bond, that is alkene. So the hybridization will be sp2 hybridization. And alkynes, carbon is bonded with triple bonds, that is sp hybridization. So the s orbital, the p orbital of carbon and s orbital of hydrogen will be mixed in similar proportion, that is 50-50 percentage, so that it will give sp hybridization. Okay, so here the hybridization of s character or s percentage of s character is very important, because then only we can know whether the hybridization is more strong or more weaker than. Okay, so in this sp3 hybridization there are 4 types of atomic orbitals have involved, right? So s orbital 1 and p orbital 3. So here we end up with sp3 hybridization. Okay, so in total 4 hybridized orbital. So cumulatively it will give 100%. Okay, so that's, so 100 divided by 4 is equal to 25%, because only one s orbital is involved. So the percentage of s orbital is 25%. Okay, and next one is sp3 hybridization, where next one is sp2, where s is 1 and p orbital is 2. So 3, so here we will have 100 divided by 3, that is 33.3. Okay, so sp3 hybridization will have 33.3% of s character. And next one is sp, so s orbital 1 and p orbital 1, 2 orbital. So 100 divided by 2 will have 50%. So sp hybridized orbital will have 50% of s character. So if the s character is increasing, s character is increased, so the acidic nature of that orbital of that compound will increase. Okay, so in other words, this acidic character or acidic nature we can say in electronegativity. Okay, so electronegativity is very important term. Okay, so the electronegativity is nothing but how much desperation it has to attain electrons from some other atom which is directly bonded to that atom. Okay, so that is electronegativity. In periodic table, electronegativity will increase as we go left to right. Okay, because halogens will have ns2np5 and inert gases will have ns2np6, which is more stable electronic configuration. To attain this more stable electron configuration, so rest the before elements in periodic table will have the desperation to get that electrons. Okay, to attain this ns2np6 complete octet electrons. Okay, so that's why the electronegativity will increase. Here in organic chemistry we are discussing the s character with electronegativity. Okay, because the s character will have electronegativity resemblance. So that's why if the s character is increased in this hybridization, so the electronegativity of that bond or that atom, that carbon will be maximum. Okay, so electronegativity is here we have to discuss in this manner. Okay, so here again this is sp3 hybridization, sp2 hybridization and sp hybridization. So if you could know that this is only the hybridization we can witness in organic chemistry, or else some other intermediates will have that hybridization also. So carbon will form the intermediates called carbocation and carbanion and carbon free radical. Okay, so these are the intermediates which forms the carbon. Okay, so in this cation means there is less of electrons, and anion means electrons are rich, and carbon free radical is only one electron is there, whether it has to have 2 electrons, so that here only one electron is, so we can refer this one as free radical. Okay, so why this carbon is very much important or very prudent to this organic chemistry means there are 4 facts which evolves this carbon as very fundamental element in this organic chemistry. That one is tetravalency, and next one is catenation, and third isomerism, and fourth point is multiple bonds. So these 4 facts are emphasizing carbon is the most fundamental element in this organic chemistry. So first one is tetravalency. Tetra means 4. So the carbon must have 4 bonds. Okay, so that is tetravalency. Catenation is nothing but how much ability it has to lengthen its chain. So that is catenation. So it will go on n times. Like if we in this carbon is 2 atoms. So we can see carbon like CH3 here, then is not a significant number because it is, we can prolong it. Okay, so that's why the catenation is maximum in carbon. And next one is isomerism. Isomerism is nothing but same molecular formula it will have, then the properties of that compounds will differ. Okay, so next one, carbon will have, as we see in this chapter, it is single bond, double bond, triple bond. So the multiple bonds are very prudent in this carbon as a element which is involving in organic chemistry. Okay, so how could we explain this tetravalency in carbon? So if you see the atomic orbitals of electronic configuration of carbon is, so the atomic number is 6, right? So this is 2s orbital or 1s, 2s, 2p, right? So 2s, 1s orbital, there will be 2 electrons, and 2s, 2 electrons. Okay, and 2p, only 2 electrons will be there. So in total we will have 2 plus 2 and plus 2, 6 electrons we will have. Okay, so here in general or ground state, when it is excited, so excited state only we will witness in most of the molecules. So this 2s orbital will jump over into 2p orbital, the vacant 2pz orbital. This is 2pz, 2py and 2px. Okay, so this electron will shift to here in excited state. So in total we will have 4 unpaired electrons. That's why yes, here p orbitals are 3. So in general saturated molecules will have sp3 hybridization. Okay, so here it explains the 4 valence bond, that is 4 unpaired electrons. It is only the feasible electrons to make tetravalency. And catenation, as we discussed, so the number of carbon chain will be elongated. So okay, so next one, isomerism. Isomerism is nothing but same molecular formula, the compounds will have same molecular formula, but the property, either physical and chemical properties, will be differ. Okay, so that phenomena can be known as isomerism. Isomerism is very important in organic chemistry. When we deal about many compounds, we will witness about isomerism. Isomerisms are structural and configurational. In structural we will have 5 types of isomerism, and configurational there are 2 types. One is geometrical and conformational. Geometrical, either it can be 2 set of isomers, that is optical and geometrical isomerism. Okay, so this is all about the general concepts of organic chemistry. So the intermediates of carbon is carbocation and C minus, that is carbanion, and this one is carbon free radical. Okay, so here the carbon is in positive state, right? So as we see in the carbon will have tetravalency. So there are 4 bonds in one carbon. So here it is positive in nature. How it could be established? Because the one bond of carbon will have to leave away from its one. Okay, so then we will have carbocation and some other atoms are like having Z as anion. Okay, so this is in terms of carbocation. Okay, so here if we discuss about the electrons in this carbocation, so there are 4 bonds, right? So in 4 bonds, carbon will have 8 electrons. Here carbocation. Okay, so only 1 2 3 bonds are there. So here carbon will have 6 electrons because each bonds are carrying 2 electrons. So this is most stable electronic configuration. That's why the carbon will have 4 bonds. Here only 6 electrons. Okay, so there are 2 electrons are missing. That's why only the carbon is carrying positive charge. So positive charges are nothing but the atoms is in electronically deficient state. Okay, so that's why carbon is stated as carbocation. So this is completely octet obeying. Okay, here less octet because there are 2 electrons are missing, right? So less electrons. So in other words, this can be named as electrophile. Electrophiles are nothing but the atoms is in positive charge. The positive charge can be attained by losing of electrons. Okay, so this carbon having 6 electrons less octet, so it will perform as electrophile. It is perform as electrophile. And next one is carbanion. See, so carbon will have 4 bonds. Okay, so here the carbon will have positive charge, right? Sorry, negative charge. So in that, so 6 electrons in 3 bonds and 2 more electrons in negative. Okay, in total 8 electrons. So this is also following octet. So it will act as nucleophile. Okay, so completely 8 electrons, but it will perform as nucleophile. Nucleophiles are nothing but electronically rich species. Okay, so the electronically rich species can be added with double bonds and triple bonds. Those are all electrophilic bonds. Okay, so where the electrons in oscillating with 2 carbons or 2 atoms which is directly bonded to that atoms, so that is electrophilic bonds, we can name it. So there this nucleophile can be added in that substrate, whereas in it's like carbon double bond. Okay, so or else single bond. If we have less electronegative compounds like CH, okay, CH3, where we can add nucleophile. Okay, so can be substituted as CH3 and nucleophile. So this is nucleophilic substitution. Okay, nucleophilic substitution. Here electrophilic substitutions are nothing but C double bond C. So this is electrophilic bond. We can add this nucleophile here. Okay, so C single bond C and here one nucleophile. Okay, so this is the electrophilic addition and this one is nucleophilic addition. One more intermediate is nothing but carbon free radical. Okay, so these 2 intermediates can be obtained by heterolysis. Okay, heterolysis is nothing but when the bond is broken, 2 different ions can be obtained. So that is heterolysis. See, here carbon is in positive charge, here negative charge, right? So there are 2 types of ions. So this cleavage can be obtained by heterolysis. And next one is homolysis. Homolysis means it will be in another atom. So we will have C and free radical and Z is free radical. Okay, so this free radical also electrophile because the free radical will have this geometry like, so 1 2 3, right? So 6 electrons, here only 1 electron, 1, so it will end up with 7. So this is also less octet, so it will also in electrophilic reagent, it is also can performed as electrophilic. Okay, so there are 3 intermediates, very important intermediates. One is carbocation and next one is carbanion and another one is carbon free radical. Carbocation and carbanion can be obtained by heterolysis. Okay, so carbon free radical can be obtained by homolysis. Homolysis is nothing but when the covalent bond is there. Covalent bonds are nothing but the mutually share of electrons, right? Carbon is bonded with another atom by sharing mutual electrons, right? One electron is being shared by carbon and another one will be shared by that X atom. So the sharing of mutual electrons will result covalent bond. When the covalent bond is broken, so each electron is carried away by each atoms, those in bond. So that cleavage is named as homolysis, right? So and the next one is heterolysis. Heterolysis same. The carbon and another X atom is bonded with carbon and another atom X atom is bonded with covalent. But here, if this X atom electronegativity is maximum, so these two electrons is being full over by this X atom. So it will X minus and this one will form as C plus. Okay, so this is carbocation. In contrast to this one, the carbanion will be different, right? So carbanion C, the same X1, but here the carbon is more electronegative than X. Okay, so these two electrons is been pulled over by carbon. So carbon will have minus charge and X will have positive charge. Okay, so these two types of cleavages are heterolytic cleavages. So heterolytic cleavages are more predominant in acids and bases and some other ionic compounds. Okay, so this heterolysis is very important and homolysis also important because the free radical mechanism is very rapid one, right? So when we see the reactions of halogenation and polymerization reaction, those are all in very rapid rate. Okay, so that will have this free radical mechanism. And carbocation, carbanion will be have more like SN1 and SN2. SN1 reaction we will have carbocation. So the stability of carbocation and stability of carbanion. So these topics and these intermediates are very essential in this organic compounds. Okay, so again three intermediates. These two are made up by heterolysis and this one is homolysis. So heterolysis is nothing but the bond is breaking, two different types of ions are formed, and homolysis only free radicals are obtained. Okay, so further classes can be explained more. So thank you.